Hey guys, today I figured we could touch base on something that most people probably don't know existed. Today I'd like to talk about ISA server. So what is ISA server? Well, ISA actually is ISA, which stands for the Microsoft Internet Security and Acceleration Server. And it came out in roughly about 1997, 98, somewhere around that time frame. And what it was a full-on proxy firewall. Because the internet was so slow back in the 2000s, in the early 2000s, mid 2000s, before we really had broadband cable, we had DSL, we had dial-up, we had ISDN, but they weren't fast. So what the ISA server did was not only give you a firewall, but it also gave you a way of loading websites faster, because it would cache the majority of the sites that businesses use to get out to the internet. So that way, when somebody goes to a cached site, it would download the site from the internal server and only update the site based off of the information that was on the actual website. So if things changed daily like a news site would, it would download the majority of the page and the page configuration from the ISA server and then download the changes themselves from the web. Now, ISA existed till probably about 2006, somewhere around that time frame. I think with all the updates and the service packs and everything else, it existed till about 2009 before it was killed off. When it was killed off, Microsoft released it again. They just changed the name of it. It then became the Microsoft Forefront server, which I think a lot of people in the tech industry probably have heard of, likely not used, but have heard of. And what that was a combination of the ISA server, but now it also gave you the ability to use it as like a proxy service, like a IPS, where you could filter web-based traffic. So you could create trusts, you could create untrusts, you could create static routes, and you could block, like adult content websites. It would give you the ability to add the security that didn't exist in the ISA server to the actual proxy or the firewall, which in essence this was. It was just a firewall, a Microsoft firewall. So this Microsoft firewall existed really in a few different iterations, with the last version being the Microsoft Forefront Threat Management Gateway in 2010. And that particular version was supported until 2020. So why was it killed? The reality is that it wasn't killed because the product was bad. It actually went through a few iterations, a few changes over the years, and it became better and more developed. It really existed for an on-prem solution from about 1997 till about 2020. But what they did is they just renamed it and then made it a paid service versus a one-time fee that you would run on-prem. So initially it was renamed Microsoft Defender. And Microsoft Defender had the ability to run it as a proxy service on your internal network shortly. It was very brief. It was part of the Office 365 or the Azure configuration initially. And then it was renamed again to the Microsoft Defender for Identity Connectivity, which is part of the Azure group, which is a paid service that you get with like an enterprise license. But all that is an ISA server that has taken transitions through the years and become more upgraded and more usable. So I'd like to show you in today's video where it all started, what ISA looked like, what the configuration looked like, what it was capable of doing, and then maybe we could test it on a Windows 10 machine and see if we could get it to work. Okay guys, so welcome to ISA. So let's take a look at what ISA is. So this is ISA. ISA actually gives you the ability to create a proxy-based firewall, and the configuration is pretty in-depth. During the installation process, the prereqs for this really require a Microsoft Exchange server. They also require a certificate authority. You need to have a self-signed certificate. You also need the ability to sign publicly a certificate. You'll need to configure your outward route, your modem or whatever, to use a NAT to actually connect to this thing for your internet traffic. And then you'll also need two NICs. You'll need an internal NIC and an external NIC. And that is how you'll set up your communication configuration to the outside. So let's start with the basics on this configuration. We're going to let the wizard run us through the step-by-step configuration on the actual ISA server, so I can show you what you would do primarily to configure an ISA server. Okay, so step one, we're going to just click on the Internet Security and Acceleration Server icon at the top of the ISA Management Console, and we're going to click on the Getting Started wizard. So now it's going to tell us that, welcome to the new and exciting ISA server. We're going to click on Next. We're going to have to set the policy elements. So basically what the policy elements will allow you to do is create security groups to allow certain users certain access to restricted websites and deny certain users access to those restricted websites. So for instance, if you were in a situation where maybe you need certain people to go to a specific Facebook website or something like that, social media, right? And those people are in your marketing department, but you don't want the rest of your company going to Facebook, this is where you would do it. You would create yourself policy elements to allow specific users, computers, groups, or schedules, all that stuff to connect to specific sites at specific times. Okay guys, so for the sake of this, what we're going to do is we're going to just configure users and groups as our select for our selected policy elements. Now keep in mind, this does not mean that we're going to configure the actual groups for the configuration right now. What this means is that when we go through the process of this full selected configuration here, this full wizard, that it's going to define this as using users and groups instead of using computers and IP addresses. So it changes the wizard configuration slightly as you go through it, depending on what you actually set as your configuration. For the sake of this, and for the sake of how modern infrastructure works, I would just suggest using users and groups just because it's easier to do that than it is to use IP addresses, because you'll have to have statics and reservations and all that other fun stuff, and also have a keep of a list as to what user uses what machine if you decide that you want to do this. But for the sake of this, I would just use users and groups. So then you just want to click on OK, and then click on Next to forward to the next screen. Okay, so at this point now we're going to configure the protocol rules. The protocol rules are basically setting up the rules of what kind of traffic you want to allow certain users or groups. This is where you would define the specific groups and users from the previous configuration. So what we're going to do is we're going to actually create a protocol rule for internet access. You're going to have to name the rule something. So I'm going to call it YTD users. Click Next. And then under here we could see we could do all IP traffic, or selected protocols, or all IP traffic except these selected. So I'm going to just do selected protocols, and I'm going to uncheck everything except for HTTP and HTTPS, and I click Next. Then it's going to ask me to specify users and groups, which I want to apply this rule to. Now, one of the rules of thumb in the later operating systems is to not use the everyone group, right? Because you don't want everybody from the street having access to your infrastructure. But when you set up a Microsoft proxy-based firewall, you do want to use the everyone group because you want everybody that has a commuter or connection or whatever else on your intranet that wants to get to the internet to pass through this actual device before they could get to the internet. So for that, it would just click everyone and click OK. You'll see everyone account, and click Next and click Finish. And there we go. We got the YTD users, and that's configured now to allow specific traffic to specific things. Now you could itemize this by creating multiples. So you could continue to create multiple different accounts as to who you want to have access to certain things. Like you could add protocols into this at a later point. So we could say, if you don't want people to have SSH access, you could deny it. If you want a person to have FTP access but then not have access to the internet, you could do that too. And you would just go through this so on and so forth. So once you're done with that, we'll just click on Next. Okay, so now we're at the part where we're going to configure what the ISA role actually is. So what is the ISA server going to do? Okay, so what we're going to do is we're going to click on Secure Your ISA Server. And you get a notification about the configuration. Click Next. And at this point, we have a choice as to how we want to set this up. Do we want to use dedicated, which is to appropriate for very secure, in other words, it's a standalone firewall. Basically, this will work just like you would have, an appliance-based firewall, right? So everything proxies through this thing. This is your gateway out to the internet. Or do you want to have it like limited services? So for that, you're technically a firewall, but it's also something you can install on the domain controller. So you could use like authentication-based access out to the internet, where you could block everything that doesn't have a username and password on your infrastructure from getting out to the internet. Or if you want to do secure. So for firewalls that are database servers or application servers. So basically that is your proxy for your app server. So if you have like a web server and you wanted to block traffic to the web server from only specific sites or specific users on specific IP addresses, or if you wanted to open up your database, your SQL server, to the outside world, but you didn't want everybody to have access to it, maybe you wanted to filter by IP, username, you wanted to filter by password, you wanted to filter by location, you want to set up geofencing, that's how you would configure this. This didn't give you the ability to use all three of them from one ISA server. You could make upstream and downstream servers. You could have multiple ISA servers on your infrastructure. You would need one for your control of your applications and your SQL box. You'd need one for your AD authentication. Then you'd need a standalone one if you wanted to use it for everyone, like a guest Wi-Fi network. But that's what this would give you the ability to do. So for the sake of this, we're just going to use dedicated, and we're going to click on next. And then we're going to click on finish. And that's going to write the dedicated configuration that we just put into the system into the actual domain controller. So your DC, which is tied to your certificate server, which is tied to everything, would then get the schema added from the ISA server written back to the domain controller, which would give you the ability then to configure your security settings. It would automate the process of group policy on your infrastructure, specifically for the use of ISA services. So once it's finished, you'll get a prompt that says you have to reboot the server for the configuration steps to take place. Just click on OK, and we're going to move on to next. Okay, guys, so at this point, once we've clicked next, now we have to do the configuration for the firewall itself. It's not as in-depth as a later firewall configuration is, so you're not going to have as many options in here initially during the configuration wizard. So you're just going to click on the configuration icon here. And once you do that, you'll get general. We have right now, we'll enable the packet filtering, enable intrusion detection. That's standard. We want to do packet filtering, enable filtering of IP fragments. So basically, if we're not getting full packets from the internet, we want to drop them so they don't hurt our internal clients. Then we're going to go to intrusion detection, and we're going to say out of band like WinNuke, ping of death, UDP bombs, or port scans. Check those. Down here, you're going to have detect after attacks on 10 well-known ports, and detect after attacks on 20 ports. So in other words, what this would do is if it's a well-known port and it keeps getting hit over and over and over again, after 10 of those hits, the system will start to scan to see if you're getting port scanned and actually stop that from happening. Now keep in mind, chances are this is not going to work in Windows 10 and 11 because Windows 10 and 11 use something called dynamic port mapping. So well-known ports don't necessarily mean they're well-known ports unless they're inbound. So it's not necessary if you're using desktops. If you're using this for the application server, or you're using this for SQL, or using this part of your Active Directory structure, that's when you want to click the port scan thing because those will still use well-known inbound ports. If not, don't bother because you're not going to collect anything. It likely will stop traffic that is real traffic versus what's not. And that's the changes that have taken place over infrastructure over the years. Next thing we're going to do is click on the PPTP. We're not going to configure this. We don't have that protocol configured on anything, so there's no reason to. So I'm just going to click apply and click OK, and then we're going to click on next. Okay, so at this point, after you click on next, you're going to get to a location here that obviously nobody's going to configure, right? Because we don't use dial-up anymore for anything. I mean, there's down here the H.323 gateway. That gatekeeper is actually configuration for VoIP-based phones. So like if you have a phone network that you wanted to configure for VoIP, that's where you would do it. Where we are right now for dial-up entries is really for internet access. It's not really designed for like POTS. So I would say at this point we could just click on next. All right, so now we're at the point where we would configure a NAT. This is not like you would think normally a NAT would be. This is actually a configuration for your upstream or your downstream servers. So if you click on the configure routing, this is where you would see the ability to configure NAT to a chain of computers. So in other words, if you had your application server and you had your domain controller server, and then you had your firewall configuration. This is where you would chain them all together, is through this configuration here. Not necessary for this because we don't have more than one, and there's really no reason to do that any longer because of modern securities built into the operating systems. But for the sake of this, I just figured I would click on it to show you, and you're just going to click next. Okay, so in this part, this is where we're going to configure the web application portion. Now this part is actually important if you're going to actually use this system. And the reason why is this is where you're going to tie your SSL cert to the actual system's ability to filter the IP traffic. Now, if you don't have an SSL cert, you could still use HTTP traffic, but if the website doesn't support HTTP traffic anymore and it's only HTTPS, you need a signed certificate. So what we're going to do is we're going to actually just click on the configure a routing rule for web. And once we do that, we're going to see the action, specifically process request by, and then retrieve them directly from the specified destination. I don't really have an upstream server, so there's no real reason to configure anything else in here. Bridging is redirect the HTTP traffic as HTTPS. And generally speaking, when you do a configuration like this, you do want to choose these options to do the SSL requests and the SSL requests and require SSL, and then you would add your certificate here. I don't have a certificate server configured for the sake of this. I installed this server just as a demonstration as to what it would be used for. So this is not going to work for me. And if I change this to regular HTTP, I already know that that won't work because most sites out there no longer allow you to use HTTP traffic any longer. And rightfully so for security purposes. But when the system was out, a lot of the major websites still use HTTP. It was very rare to find HTTPS on the internet. Under general, this is just the name of the rule. Destinations applies to all destinations because we had configured this to retrieve them from specified destinations. So in other words, it comes directly from the machines. So at that point, we just click on OK, and that's the default rule. By default, that's the configuration. Now, if you change that, you can change the name, but for the sake of this, it's just the default. So after you do that, you just click on Next, and now you'll have to register the ISA server. So the registration for the ISA server is actually a web-based registration, like to a website that Microsoft no longer hosts for obvious reasons. So if you click on that link, all it does is it brings you to a website that you can't register the server any longer. And all the registration really did was give you the ability to, get product updates and notifications for product changes in the future. So for the sake of this, we don't have to click on it. We're just going to click on Finish. And then once we finish it, we're going to reboot the server. Okay guys, welcome back. So we're logged back in, or at the login screen, I should say, for the ISA server. And you'll see here that the username is no longer present. It's no longer auto-filled. And that's part of the ISA configuration that takes place on the group policy backend. I figured it would be important to show you that. So make sure you know what your username is before you reboot the server that last time for the ISA configuration. Okay, so now that the server's back up and we're logged back into it, we have opened the ISA console again. At this point, this is when we're going to do the configuration of our network adapters. Now you need static IPs, you can't use reservations, the system doesn't like that stuff, so you'll need to at least carve out two IP addresses, an internal and an external. So your internal obviously should be your LAN address, your gateway. So if you use like a 192.168.1.1, that's what the system's IP address should be on the LAN side. And then on the WAN side, or the secondary NIC, should be whatever you're going to use as your outbound. So if you have another firewall and a VLAN, you'll just have to carve out a gateway to the internet on the WAN side. If not, and you're plugged in directly to your modem, then you'll just have to figure out what it would give you DHCP and then set it static for that address on the WAN side. Once you have those things both configured, you'll actually have to reboot the server again because the ISA services register the IP addresses with the application on boot. So if those IP addresses didn't exist and were changed, you'll need to restart the server in order for them to populate correctly in the ISA configuration. So once you have the IP addresses set and you've rebooted the box and you get back to the screen, what you're going to do is you're going to expand the servers and arrays, and then you'll find your server name. You'll right-click on this and you'll go to Properties. And in here is where you're going to do the configuration for the incoming and the outgoing. So the incoming should be your internal IP address. So your WAN, your LAN, and the loopback. And then you should have the SSL listener enabled. And then you should also do the outbound or outgoing web requests and have that to use the listener configuration on all internal IP addresses. So basically what that'll allow you to do is to route your internal traffic to your internal LAN IP addresses, and then route your external traffic to all IP addresses. And the reason why that matters is because the ISA server isn't smart enough to use the static IP address of your WAN, because you can only have a single gateway. So you're going to route the traffic differently. The actual ISA server configuration routes it. You don't need the gateway configuration in the actual NIC, right? You're only allowed to use a single gateway. You're going to use the gateway configuration for your LAN, so that way your communication can take place between your clients. On the WAN side, there's no gateway configuration. So as a result, what you're doing is you're pointing this system to all addresses, so that way the system can determine how to route the traffic outbound to connect. Once you have that set, you have your SSL enabled, you're going to go over to the auto discover, make sure that you don't have this set. Go to performance, and if you have 100,000, more than 1,000 clients, then you'll have to set it by here. Obviously, for the sake of this, it's a single desktop, so we're just going to do fewer than 100, and then we're going to hit OK, and then you're going to reboot the server again. And when the server comes back up this time, let's jump over to the client and test this out. Now, I already know that it's not going to work because we don't have a signed certificate, but we should be able to at least prove the route. So just keep an eye here that the server name is YTDISA2K. Let's jump over to the desktop after a reboot and see what the desktop looks like. Okay, so now that we're on the desktop, this is a Windows 10 machine. This machine is actually on a Windows 2000 domain. I'll have a future video on how to do that. But in essence, what we're going to do here is we're going to configure this particular desktop to use the proxy-based configuration, and then we're going to test with HTTP because we know that we can't use HTTPS, and we're going to see what the actual error shows. It should show the proxy-based error for the non-SSL certificate, and the reason why is because we can't do a redirect to SSL, which is required for these websites to work today. So let's start by configuring this thing to use the proxy. So what you do is you go to Start, you go to Settings, you go to Network and Internet, click on Proxy, scroll down, and then you're going to set your proxy services. So we know that the proxy server is set to my gateway, which is 192.168.242.1, and we know the proxy service by default is listening on 8080. So once we do that, that's the configuration on the proxy. The next thing we're going to do now is we're going to just open up a browser, and we're going to go to google.com, but we're going to define it specifically as HTTP. So there we go. So we now know that it works because we have the error here. It says specifically the ISA server requires a secure channel connection to fulfill the request. The ISA server is configured to respond outgoing secure. That is secure socket layer SSL channel requests. And then it tells me that the Internet Security and Acceleration Server specifically. So that's the ISA server that we were just on. And then it tells me that we couldn't retrieve the requested page and the ISA server's name. And then it shows me the non-SSL version of the website I'm trying to get to. So basically this proves that yes, the ISA server is running, and yes, you could still use it as a firewall. In essence, if you really wanted to, and you wanted to install this on a 2000 box and put this on a small, like maybe one of those tiny little Chinese desktop machines with 2 NICs, obviously not a B-Link if you've seen the other video, but at any rate, if you get one of those things with 2 network adapters, put Windows 2000 server on it, install the ISA 2000 or 2004 edition, and you can find a key to install it, then you could run the ISA server as a firewall on a Windows 2000 box on a small piece of hardware. The requirements for the system to work in reality are about, for modern traffic in a household with maybe at the most 20 machines connected at a time, is really about 512 megs of RAM, 1 core, at least a Pentium 2. It should be fine to run on anything that's modern. Even like the Celeron, the cheapest machines you could find, it should run absolutely fine. But you'll still need a signed certificate. So you need to figure out how to get that configured without having an Active Directory server, and then you should be fine to just run it standalone. Hopefully this is helpful. Hopefully this is insightful, and hopefully this is something that maybe you learned, because this is really an operating system and configuration that I think the majority of current technical engineers and technicians have no idea even existed. Like and subscribe for more content, guys. Take it easy.